All right. We're going to focus today on review sheet number 1. Guys, the problems on both review sheets are pretty much the same. So it'll just help us be more organized. We'll just look at worksheet number 1. All right, so we're going to sketch this equation. Now, first of all, there's a lot going on here. So before I even start, I want to remind you that we are more used to seeing that 2 at the end of the equation. So you do not have to do this, but does it make sense to you that those are the same thing? And then when I put it out here, then I can clearly see what is that. That's my vertical shift. All right, so I know I'm going to have a vertical shift of 2. Now another thing that has to happen is that guy right there can't be there. He has to be brought out. He has to be factored out. I am a grown-up kid. I mean, you are grown-up kids. This is not confusing to you. Factoring is division. When you take out a 5, you're factoring out, you're dividing it out, so this is going to be pi over 10. And if you're not sure about it, what happens when I multiply 5 times 1/10? I get 1/2. So if you're not sure, you can always check yourself to make sure. Now the equation looks more like I'm used to seeing it look. So, it's a cosecant. Each of you has your own style. I never graph a cosecant first. I'm going to think of this as a sine, because sine and cosecant are reciprocals. Sine is one of my BFFs. I'm really comfortable with sine. So I'm going to graph this as a sine equation. I will make whatever changes I need to make, but I'm going to start with a sine. I'm also going to wait and do this in a little bit because I get confused with so much going on. You can do it all at once. I'm fine with you doing it all at once. But remember, I'm 64. It takes me a while. So I'm going to graph this right here in my purple marker. I'm going to graph this right here. All right, so here I go. Looks like I have an amplitude of 4. So 4, -4. Looks like I have a phase shift of pi over 10, which means that my negative sine curve is going to start, is going to start at pi over 10. Is that ringing some bells, memory bells there? It's negative. Now, what is the period of this thing? Because I know where it starts. Now I need to figure out where it ends. Well, what's its period? 2 pi over 5, which for my purposes, could I think of that as 4/10? That might help me because I know it starts at 1/10 and travels 4/10. So it's going to end at 5/10. Now, I know that's 1/2. If you want to make that 1/2, that's fine. I am not going to penalize you for not simplifying these fractions because now I need to find the midpoint. And if I leave them all with the same denominator, it's going to be easier. So 1 and 5, I guess that middle is 3/10. And then 1 and 3 is, the midpoint's going to be 2/10. And this one's going to be 4/10. And again, no need to reduce those fractions for me, but if you want to do it, do it. Absolutely. All right. Now, remember, in the this was not a sine. This was a cosecant. So I am going to drop asymptotes in every place that the sign is 0. In other words, every time it crosses the x-axis, I'm going to put in an asymptote. Because the reciprocal of 0 is 0, or is undefined, asymptote, okay? Now, I'm going to take these curves and I'm going to flip them. George, have I made a mistake? Is that what you're signaling me for?
What about the vertical shift?
I'm going to do that in a minute. Because that 2 is actually getting added to the cosecant. So I'm going to go ahead and draw my cosecant, which I have done. And now I'm going to take the whole shebang and lift it up 2. Now, you might have done things in a different order than me, and I don't care. It doesn't matter. That's fine. That's absolutely fine. But everything's coming up 2. So now the top of my cosecant's not going to change the asymptotes. The top of my cosecant this one is at -2. And the bottom of this one is going to be at 6. So George, the blue is going to be my final answer.
Do we need to erase?
Nope. You just got to make sure I know which one's the answer. So if I were turning this in, I would say blue equals final answer. If it's easier for you to erase, great. All right, Maren, does that take care of it?
Yeah.
All right. All right, who else found something we need to look at? Leah?
To number 12.
12. Kind of the backwards of what we just did. Here, the picture is given, and we're going to come up with the equation. Now, got an asymptote at pi over 6, another asymptote at 5 pi over 6, and another asymptote at 9 pi over 6, and a curve that looks like this. Now, gang, when you see that shape, you got to write 2 equations using 2 different functions. What are the functions that come to mind when you see that shape? Tangent and cotangent. So I'm going to have y equals cotangent and y equals tangent. And I'm just automatically putting in all these blanks because I just erased it. But in the problem we just did, didn't we have a number here, a number here, a number here, and a number here? Yeah, those are the 4 places we put numbers to change our graphs around. Okay? Now, no other information is provided in this problem but this. So, that shape is literally a cotangent. That's a cotangent shape. So I'm going to do that one first. That's a regular cotangent. That's what it looks like. It would probably behoove you to, over to the side, maybe sketch the regular cotangent. That's the regular cotangent.
And then a tangent to period's only pi.
Tangent to cotangent's both. The period's only pi. Yep. That's a period right there. Now notice that in the original cotangent, there's supposed to be an asymptote at 0. Right? But he's been moved over to here. So in the cotangent, my phase shift is pi over 6. Because your phase shift, your horizontal shift is your new origin. What happened to your origin? Well, got moved. Now, the original cotangent, as Leah just said, has a period of pi. This is one period and it is not pi. What is this? 4 pi over 6. So the period of this one is 4 pi over 6. Now think about the problem we just did. When we had to find the period of the thing we just drew, we took 2 pi and divided it by this number. Well, in that problem we used 2 pi because that was a sign. In this one we're going to use pi. We're going to divide it by this number, and that has to give us 4 pi over 6. That's how it works. Your standard period divided by this number gives you your new period. Well, we know the new period's 4 pi over 6. So I'm just going to cross multiply here. Some of you are going to do this in your head, but I got, what is that, 3 halves? So I'm going to put a 3 halves right here. It doesn't look like there's any vertical shift, and there's no way of telling if there is, right? Without any labels anywhere, it looks like there's no vertical shift on this. Also, what about this number? Well, it can be anything you want it to be, so I think I'll just leave it 1. That number, there is no amplitude on this picture, and without any labels here, I have no idea if I've adjusted the steepness or not.
Why'd you do pi divided by 1 instead of 2 pi divided by 1?
Because the period of the cotangent is pi. So I'm just gonna go ahead and leave that a 1. When I write this as a cotangent, or excuse me, as a tangent, this number, and this number aren't going to change. Because the curvature is the curvature, the period is the period, and the vertical shift's the vertical shift. Now, what will have to change is this one right here now is going to have to become negative, because a tangent looks like this. And that's upside down. Okay. This is also going to have to change, because remember, this number reflects your new origin. In a tangent, where's the what's the origin? The origin is the dot, not an asymptote, but a dot. So where's my dot up here? It's right there, right? That's going to be my phase shift, but I got to figure out what it is. What is that? 3/6. Now, for these purposes, I would probably make that pi over 2, but if you left it 3/6, I wouldn't mark it wrong. And we're done. All right, Leah? All right, Sabrina, did you also have your hand up?
Oh, I did. Let's start with like 7.
7? Okay, what do I need to remember about frequency? How do I find frequency? Reciprocal of period. So frequency is going to be the reciprocal of the period. So all I need to do is find the period of this curve. Okay?
Is that like 10?
Well, how do I find period?
Is it not 1?
Period is 2 pi for a sign divided by this coefficient.
So it's 25.
So the period is 20 pi, which means the frequency is 1 over 20 pi.
There we go.
Okay? Finley? You have your hand up?
I just wondering what number. 7.
Yeah, that was 7. You didn't have your hand up for a question? All right, who else has a question? Anybody else? Peter?
For number 3,
Number 3, yes. Number 3 will be a calculator problem.
and then when you get the answer,
Let's just do number 3. Okay, so, this review sheet, I do not have really delineated. I don't know if I did it at all. Which ones are calculator and no calculator? Well, so far, everything I've done, I've not needed a calculator for. But I do need a calculator for problem number 3, and here's why. When I divide, I get 4/3. If I'm gonna do this without a calculator, the only numbers I can handle are the 1, root 3, 2, 1, 1, root 2, the special triangles. This, I can draw a triangle that has a tangent of 4/3. And I know that I can find the hypotenuse, but I have no idea what that angle is, and that's my job, right? My job is to find the angle. So, before I go any farther, I'm gonna use a calculator, but before I do, I'm gonna remember that the tangent can also be positive in quadrant 3. So there are 2 places that x could be. And x is gonna be whatever angle has a tangent of 4/3. Now, I do need to be set in radians, because the directions say 0 to 2 pi. So I need to be set in radians, and then second tangent, 4/3. So, probably no rounding, let's just do 100. So that would be 0.93. So my answers are 0.93 and pi plus 0.93, which is 4.07. Yeah. So there are your 2 answers to the problem. Yes?
Since it's like a special triangle, wouldn't that angle be 60 degrees?
No, this is a Pythagorean triple, but it's not, the special right triangles are 1, 2, root 3, or 1, 1, root 2. 3, 4, 5 is a Pythagorean triple, but it's not one of my special right triangles.
So which problem in the answer do you have to include plus or minus 2 pi or plus or minus 60?
If you want all of the angles, here, the
Oh, yeah, it
directions
has
clearly
this.
say 0 to 2 pi. So I'm not gonna go bigger than 2 pi. Take that, Dom, take that direction away, and then I would have to do it. Yeah. Sabrina?
Could you do 9?
9.
You just plug it in your calculator?
No. When it says find the exact value, that means no calculator. This would be on the no calculator part of the test. Alright? So tan negative 2021 pi. Alright? Now, wait a minute, Miss Ford, you're not letting me use a calculator. Yes, I'm not. Think about this angle. Yes, that's a big number. But think about it for a minute. Every time I go around my circle, is what? Well, it's 360 degrees, but it's 2 pi radians. So what if I thought of this as negative 202 pi, negative 2020 pi minus another pi? Is that, I'm kind of just thinking about this in my head, is that right? What does this represent? It's an even number of pies, so doesn't it just represent a whole bunch of spins?
Yeah.
So this part of the angle is like zoom, 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 zoom. Don't care about it. This extra part though, I do care about. So negative pi would be right here. That's the extra pi. Remember, only even pies are revolutions. So this is the point negative 1, 0. I want the tangent. What's tangent by definition? I know it's opposite or adjacent. What else is it?
Y over X.
Y over X. So 0 over -1, the answer is 0. All right, Kylie, you had your hand up?
Oh, yeah, could we do 5B?
5B. Okay, it's exactly like what I used to right here, only it's actually easier. And ironically, it's exactly the same angle. It says find the side of 180. So on my circle, where's 180? Right there, right? So that's the point, -1, 0. What's sine? Not opposite or hypotenuse, what's the other definition? Y over R. Now, using my unit circle, which, I mean, you might have the whole thing memorized, and if you do, that's great. But using my unit circle, I know X is -1, Y is 0, and R is 0. I mean, R is 1. So Y over R will be 0 over 1, which is 0. Now, how did I know that was gonna be on the circle? Because 180 is on an axis, right? If it had been 120 or something, I would be drawing a triangle to look at it. But 180 is on the circle.
Yeah.
All right, who else? Yep, Sammy.
4B. Not that.
4B. 4B. Find, do this exact, this is a no calculator problem. Find S if theta is 1.2 and the area of the circle
Great.
is 10. All right, now I want to find radius. Wait,
What's the formula for
oh no, it says find S, that's what I'm finding, I was saying, wait, radius. Okay, now if the area of the circle is 10, what's the radius? What do I know about area of the circle? Pi r squared equals 10. So r squared is 10 over pi. Now, it says exact, so I'm not typing anything in on my calculator, I'm just gonna deal with whatever. So the radius is the square root of 10 over pi. Not nice, but that's what it is. Now, how do I find arc length? Radius times radians. Do I have my radius? Yep. Do I have the radian measure my angle? Yep. I'm done. Arc length equals the radius times 1.2. I would probably write that 1.2 just to avoid confusion. There it is. That's it.
We can leave a square root in the denominator.
Well, keep in mind that pi is itself irrational, so rationalizing it wouldn't help a single thing. So, yeah. Test. Find the area of the shaded. So, in other words, find the area of the sector. If the angle is 150 degrees and the radius is 6. What's the area of the whole circle? Wouldn't the area of the whole circle be 36.5? So guys, I want you to think about something for a minute. What if I took this circle with a radius of 6 and said find the area of that?
Just divide it by 2.
It'd be half, right? Well, what if I said find the area of this? It'd be a fourth. And the reason it would be a fourth is because 90 is a fourth of 360? Well, I want what fraction of the whole area? Know what I want? 153/60ths of the whole.
So 15.
And so to the mathematician, of means times. So I'm just going to take 1536, I'm gonna cancel those zeros, times 36 pi, it's 15 pi. All right, let's not get confused, let's keep an open mind. Sabrina?
Quentin, 10.
Have you tried any of these?
Oh, yeah, no, I did some on the front page.
A wheel,
Number 10.
a wheel with a 10-inch radius turns out 1,500 revolutions per minute. Okay? So I am starting with that value, and I want to know how far it will travel in 8 hours. All right. So first of all, how far it's going to travel? Well, every revolution is how far? What distance is every revolution?
20 pi.
20 pi inches. So 20 pi inches is one revolution. Would everybody agree with that?
Oh, it's just times 5.
It's a 10-inch radius.
Okay. That's some easier than I thought it was.
Okay. Now, I want it to travel for 8 hours. Right? So, let's see, I've got minutes. So, 60 minutes is 1 hour. But I need to times that by 8, don't I somehow? I'm gonna wait on that for a minute, do that later. What have I got so far? What have I figured out so far? This is gone. This is gone. So I've got inches per hour. So inches per hour. Listen, I want to know how far it goes in 8 hours. So could I times that by 8 and know how many inches it travels in 8 hours? So I'm just going to multiply that 8 over 1. There's no unit really there because I just want it to go 8 times. And now I know how many inches it's going to travel in 8 hours. And what did the question say? How far will it travel? I'm going to look at this number. I may want to change it.
Gosh, probably 12.
45 times 1,500
It's still a lot of feet.
times 60 times 8. Okay. Let's talk about this. If I leave it this way, and if I typed in all the numbers right, wrote down all the numbers, this is how many inches it will travel in 8 hours. Well, that's kind of a stupid number, right? I mean, it's huge. So what could I do to make this a more reasonable number? What could I do?
Divided by 20.
Divided by 12.
Well, if I divide it by 12, then I would know how many feet it traveled. It's still ungodly. So I'll divide it by 5,280. So 713. Actually, it's going to travel almost exactly 714 miles.
So that you could also just solve for the miles per hour.
Yeah. So what I typed here on my calculator would just be 2 points.2 hours. Test. All right, I can't hear you. Divide it by 12 first, because like Leah said, you can do that up here. The problem didn't say to change it in a particular unit, so I just went and worked it out, and then it seemed too big. So I know that 1 foot is 12 inches, and I know that 1 mile is 5,280 feet. So that's the arithmetic that I did. So then I was left with miles. So that's how many miles I know. Okay? All right, one more question. Here we go. Who's got it? Who's got it? All right. Same question. Okay, then what do we ask it? 5C. Let's find the cosine. Find the cosine of negative 10 pi over 3. Now, this is not going to be a calculator problem. This is going to be no calculator, and again, it says exact value. That means no calculator. So, remembering that a revolution is 2 pi, this is more than a revolution. Would you agree? So it might help me to weed out the extra revolution. Wouldn't a revolution be 6 thirds? So let's get rid of 6 of these thirds. So now let's look at the cosine of negative 4 pi over 3. Now, keeping in mind that pi is 180, divided by 3 is 60, times 4 is 240. This is like finding the cosine of negative 240. Agree? So where is negative 240? Negative 240 is right here. So how big, this is the angle right here that's important, how big is that reference angle? 60. Everybody got it? 180 plus 60? And in a 30, 60, 90, this is the root 3, this is the 1, this is the 2, and that's negative in this quadrant. Now, those of you, if you have the unit circle memorized, then you know what the answer is. If you don't have the unit circle memorized, then this is what you're going to do. This is the way I do it. Because I don't want to memorize all that stuff. Now I want the cosine. What's cosine? Adjacent over hypotenuse. So the answer is negative 1/2. Now, could I have changed this into degrees right off the bat? Yes, and it would have given me negative 600. Now tell me about negative 600. It's more than 1 square. So if I took the 360 out of this, what would I be left with? Negative 240. So you can get to it.
Okay, I like it's not like the whole problem, but I just have a question on number 8. When inside of the parentheses, when you have like a negative 2x, and you take the negative 2 out, like a series is a negative. So
That's too much to talk about today. So your job is, next time we have class, which is when?
It's Monday.
Tuesday.
Tuesday.
Next time we have class, that's the first question we're gonna address, okay? So you remember to ask.
I just put a giant circle on entry and
Alright, we can't do this one, pay attention. Chris wants to change 160 degrees into radians. So, it depends, if you've memorized the little conversion, you can multiply by it, or you can remember it's all proportional. Pi radians is 180 degrees, so how many radians would be 160?
Coming to the end of our day, we hope it was a fantastic day, and we end our week as well, getting into second semester.
Alright, we reviewing it, or